Okay, this is video 8.2. We're going to be adding and subtracting rational expressions. So it's not a really vocabulary, but I added one because it's really important. It's called LCM. This is least common multiple, or adding or subtracting fractions is basically what we're doing. We have to have the least common denominator. So basically it's the smallest multiple that both the denominators can go into, not divide by, go into. So our objectives are, first we're going to determine how to find the LCM of a polynomial. Then we're going to, once we do that, then we're just going to apply fraction rules and add and subtract our rational expressions. So let's look at the example 1. Again, when we have a number 5, 6 plus 4, 9, we get the least common multiple. Let me show you the way I do it. Let's take 6 and 9. All right, this is a simple number, but it works. It just really helps to break it down. So I'm going to take my two. I have 6 and 9. So I'm going to go to the side and do this. I'm going to prime factor it out into exponential form. This means multiplication times. And I'm going to try and line up the bases as much as possible. Okay, once I've got it prime, and if you need help, you can ask me after class. So I've got technically two different bases. I'm going to take one of each one, and then the highest power. This is an implied 1, and this highest is square, and then I multiply them, so 9 times 2. So my least common multiple that both of these will go in is 18. So remember, we got to know the difference between a factor and a term, and we have to use factors when we're priming this out. Look at this polynomial. So basically, they do it the same way. I'm going to write it over here because, so it's x minus 1 times x minus 2 are the factors. Remember, this whole thing is the factor. All right, and then the second one factors out to x minus 1 times x plus 1. Again, you want to try, I'm not going to write it all out. Normally I would. And get the like bases together of each factor. So I have 3 different bases, and they're all implied to the first power. Remember, this is why you have to understand this. So I'm going to take one of each one out of each factor. The highest power is 1, 1, and 1. That is my LCM. I'm not going to go and try to fill this all in because I need to see what I'm missing. So let's look at example 1. They want us to find the LCM of, and we'll learn how to use polynomials, 6xy, 15x squared, and 9xy to the fourth. So the first thing that I'm going to do, I want to write them all out. So I've got 2 times 3, and variables are easy because they're all implied whatever power they are. So this is what? 3 and 5 and x squared. This is 3 squared x and y to the fourth. So now I'm going to take each base and I'm going to separate it. Okay, remember these are exponents. So look at the bases. So I have a 2, a 3, a 5, an x, and a y. So I have 5 different bases. I'm going to take one of each out, the highest power. 1, 2, 1, 2, 4. Now I multiply all this. So 2 times 5 is 10 times 9 is 90. So I have 90 x squared y to the fourth. It's really that simple. Now let's look at a polynomial and see what that does to our polynomial. All right, so we have y to the fourth plus 8y cubed plus 15y squared, and we have y squared minus 3y minus 40. So we've got to factor this. Now this first one factors out to y squared times, and this is not about factoring, so I'm not going to show it here, but you can, if you need help, I can help you outside of or during class. So x plus 3 times x plus 5. And this other one factors out to, let's see, 40 is 10 and 4 and 10, 8 and 5. So y minus 8 times y plus 5. Okay, I didn't do a very good job of lining them up, but I've got this base, And this is y, not x, sorry. And this base, and these. So I really have 4 bases. It's hard to tell. So I have a y, and I have a y minus 8, and I have a y plus 3, and I have a y plus 5. They're all to the power of 1, except for this y squared. Now that is my least common multiple. Okay, so now let's use this to get the least common denominator and solve. So look at example 2. So that was that. So let's look at example 2. And we'll come back to this adding rational expressions. So let's start with it. So the rule is you have to have a least common denominator to add or subtract any ratio, any fraction. Once we do that, then we simply add or subtract the numerators and keep the denominator. We do the same thing here. So let's look at example 2 with a denominator as a monomial. So if I have, first of all, I'm going to add it this way. 3y over 2x cubed plus, because I always add and subtract fractions vertically. So now I have to get a common denominator. So I'm going to come over here, 2x cubed and 8xy squared, and I'm going to prime it. So 2 times x cubed. This is 2 cubed times x times y squared. If you do it this way, prime it out, separate how many different bases we have. We have 3, sorry. The highest power is 3, 3, 2 cubed, so it's 8x cubed y squared. So again, this is my common denominator, just like you would do the fraction. That's why I do it this way, so we have room. Now remember, you still have to apply fraction rules. You're multiplying by some form of 1, and we need to see what times this number is going to equal that. Well, you can look up here or you can divide it out. You can do 8x cubed over y squared over 2 times x cubed. Well, these cancel. 1, 4, so it equals to 4y squared. That's what we need. Remember, because you have this divided by this equals this, and this times this must equal that. 6 divided by 2 equals 3, so 3 times 2 equals 6. That's all I'm doing. So that's what's going to go here, because that's what I need to multiply this to equal our common denominator. Again, do it to the top. I have a monomial times a monomial, so it's 12y cubed. Here, what am I multiplying by? Well, the 8's cancel out, so it's x squared. So 5x squared z. Now I simply add it. 12y cubed plus 5x squared z all over 8x cubed y squared. I can't factor anything out that will simplify with this, so I can just leave it like this. But make sure you keep in parentheses, because this y's and these x's don't cancel out. Remember, this plus, we just talked about it, sticks together. Okay, let's look at polynomials as denominators, meaning more than one term. So I have 5 over 6x minus 18, in parentheses help keep you organized, minus x minus 1 over 4x squared minus 14x plus 6. Well, I have to first get a common denominator. So factor out a 6, I get x minus 3. Then I have 4x squared minus 14x plus 6. I know I can factor out a 2, and I'm not going to do the factoring, but it ends up factoring to x minus 3 times 2x minus 1. Again, we can do this offline or during class or outside of class if you need help. So this is 3 times 2, right? So again, I have a 3, I have a 2, I have an x minus 3, and I have a 2. All the different bases, all the different factors. They're all implied 1. So I just simply go, okay, my LCM is 6 times x minus 3 times 2x minus 1. So then again, when it's in this form, it's easy to see what am I missing? If you go back, and this is this up here, right? So I can rewrite it. I would rewrite it normally. I wouldn't do what I just did. Okay, so what's missing here? We have a 2x minus 1, x minus 3. We have a 2 and a 6, so I need to multiply this by 3 over 3. And then I will get this. Okay, here you can see I have the 6 and the x minus 3, so I'm really multiplying this by what? 2x minus 1. And 6 times x minus 3 times 2x minus 1. All right, so remember you have a binomial, so you have to distribute, so that becomes 3x minus 3. And then we have what? 5 times a binomial, so it's 10x minus 5. So now I'm going to have 10x minus 5 minus, because I have a binomial, since I don't have a monomial, I need to put my parentheses first. And then 6 times x minus 3 times 2x minus 1. Again, you have to distribute that negative. So it's 10x minus 5 minus 3x minus 3. And that simplifies to 7x minus, oh, this is a plus. I didn't think so. Minus 2 all over your least common multiple. Again, it's tied together, so I can't factor anything out of here, and this is in factored form and nothing's the same, so that is your answer. Okay, so how do we simplify? Let's look at example 3. Let's simplify polynomials as denominators. Oh, that's what we just did. So example 4, complex fractions with different LCD. So this is the one we're going to be able to do it 2 different ways. There's a 4a and a 4b. Or actually, they just show you, example 5 shows you. You have 1 plus 1 over x divided by 1 minus x minus 1. So the first thing this one does is we have different LCDs. So what they're going to do here is they're going to take this and simplify this. So this becomes 1 over 1 plus 1 over x. So basically they get a common denominator, which is x. So this is just times 1, right? So this doesn't change. Here I'm multiplying by x over x. So I get x over x, yes? And now I simply have x plus 1 over x. That's my numerator. So I'm going to do the same thing to my denominator. So I'm going to do y over y minus x over y. So I just got the common denominator of these two. And then I end up with what? Y minus x over y. So now I'm going to rewrite this as x plus 1 over x divided by y minus x over y. I'm going to keep, change, flip. Nothing crosses out, so I just simply multiply, and they went ahead and distributed. I would have taken this times this over this times this. Or you could distribute it out like they did in the book. I will take either one. Now let's look at example 5 with a different method. So that was example 2, example 3 we went through. Let's look at example 5, which shows us a different method to do the same exact problem. So there's 4 we just did. So let's look at 5. So another method is to get the entire LCD of the entire expression. So what does that mean? So again, let's look at the problem. So we have 1 plus 1 over x divided by 1 minus x minus 1. So if we know that this is a numerator and this is a denominator, we look at every term. This has a denominator of 1 over 1 and 1 over 1. So my common denominator, if I got them, would be x and y, which is x times y. So that is my common denominator. If I get the entire, find the common denominator and multiply the entire fraction numerator by the common denominator, right? because I still have numerator, denominator. I'm still multiplying by some form of 1. So I have two terms, so it must be distributed. So I end up with xy plus, now this is where you gotta know fraction rules. The x's cancel out, I'm left with y over 1 or simply y plus y. When I do that here, I get xy minus, you have xy times x over y. My y's cancel out, I'm left with what? X squared, so minus x squared, okay, and is that what we got? Yes, so we got xy plus y over xy minus x squared. And that's as far as we go because remember this is tied together, so they can't cancel out, they're not the same. Here, if I factored it back out, I got x plus 1 over x times y minus x. Again, nothing's the same, so I would take either one of these answers. So this is just another method of doing this. All right, do the problems and we'll see you in class.